Hello again. I'm sorry for cut the video because there's time limit in there. I didn't see that until I saw the video was cut. So hello again. I will continue showing the solution for the question C. So I'll continue where I left off. So like they gave us the information is the distance from moon to earth is 239,000. I'll put this way. I don't need it yet. 239,000 miles. And yes, the height of a penny is this much. So what will and how many pennies? One penny is not a stack of 5 billion pennies or 500 billion pennies. Just one penny. How many of one pennies would need to be in a stack in order to reach the moon? So this is how much. First thing is you have to change it to proper scientific form. Is hit point, and we move over to the left, which is add the exponent to the base 10. So move 1, 2, 3, 4, 5. And also the number have to be between more than or equal to 1 and less than 10. So yes. And finally, all we have to do is be taking this and divide by this. 2.39 multiplied 10 to the power 5 divide 1.706 251,706 10 to the power -6. And yes, we keep the base of the 10 the same, and we bring the -6 up, and we'll change the sign to +6. 5 plus 6 is equal 11. And 2.39 divided by this is equal 1.4. So there you have it. This is how much pennies. How much for one? How long? How high is the one penny? And this is how much pennies required to fit the distance from the moon to the earth. So that's done. So we're done for question C. And finally we move on to the challenge D. How many times would you need to fold a piece of paper in order for it to reach the moon? Information. One piece of paper is around 0.01 centimeter thick, and the distance to moon is 384,000 kilometers away. So we have two information. It's 384,000 kilometers away and 0.01 centimeter. This has nothing to do with a penny. So we don't need to care about it anymore. We care about new units and new values. First is 0.01 centimeter. A piece of paper. 0.01 centimeter. And distance from the moon to the earth is 384,000 kilometers away. So first we have to change all the values to proper scientific form. So to change this from here, multiplication from here, you must make this number between equal to 1 or more than 1, but much less than 10. So we have to move the decimal point to the right 2 times, which is into the negative 2 minus exponent. And for this, the decimal point is over here. We move it to the left. 1, 2, 3, 4, 5. Which means add 5 with exponents. So next we will, and also we have one more data is the conversion. 1 kilometer equal 100,000 centimeter, which if we change to proper scientific form, it will be 1, 2, 3, 4, 5 multiply 10 to the power 5, because if move to the left at the exponent, each time we move the point, the decimal point. So finally we will convert the centimeter to kilometer by taking this divide by this. We like the previous, we keep the base the same. We bring this up and change the sign. Is minus 5. Keep the base the same. Minus 2 and minus 5 is negative 7. 1 is the same. 1 divided by 1 is 1. So this is the answer. 1 multiply 10 to the power negative 7 kilometer. And now we'll need this in distance from the moon. Now the equation for doing this, some of you might think that I just need to take this and divide by this and we'll find how many pieces of paper. But the question is that how many folds, not how many pieces of paper placing on top. So here is the equation for you to solve this. Is 1 multiply 10 to the power negative 7 multiply 2 to the power n equal 3.84 multiply 10 to the power 5. And also let n be the number of folds. Let n be the number of folds, and y n is the number of folds. It's the exponents, but not the number itself. Well, because here it is. Example, this is a piece of paper. So if I take this and fold it once, which mean this is, we're talking about the size, not the area of the surface. So don't worry about that. We'll worry about the height of it. So if we fold, we have 2 layers, and it's double of the initial one. It's double than the one of them. This is the first fold, and now if we fold for the second time, it will not be like this, but it will be like this, because if you fold, you're taking the 2 folds and you're taking the 2 layers and put it amongst among the other two layers, and which means like 2 by 2 layers, which makes it 4 layers. So the height is 4 times the height just after 2 folds. The first fold is 2 times height, but the second fold is 4 times height. So and after the third fold, it will double the whole everything. It will become 8 times fold. So like this, like let's take F and put example. If I replace n equal 1, which is one fold after one fold, 2 to the power 1 is 2, and this multiplied by 2 is equal something, but you know that it definitely will be twice higher than this because it's multiplied by 2. And if this multiplied by 2 and 2 to the power n, if n is 2 to the power 2 is equal 4, which means it will be 4 times higher. Just like the example I just showed you, which is true and it's relevant. It fits with the problems. Like every time you fold, it doubles of the doubles. It doubles of the doubles. It's to multiply 2 itself, and if you multiply and you fold it again, it multiplies itself. So 2 multiply 2 is 4, and multiply 2 again is 8. So 8, so mean it's double of the previous, but double of the previous, and the previous is the double of the initial, and keeps doubling. It's not like it's not like twice or 3 times, then 4 times, or then 5 times. It's double and double of the double. So this is the equation of how you should do it. And also the symbol is multiply 2. This is 3 folds to multiply 2 to the power 3, and you guess it. It is 8. It is 8, which is 8 times double of the previous is only 4 after 2 folds. After 2 folds, this 4 is Fn F2 equal F3 F1 equal 2 to the power 1 is 2, 4, and 8. Is 4 times. So there you see it. This is double of this, but this is also double of this. So this is 4 times of this after just 3 folds. So this is the equation to find out the solution to all you need to find. If you want to find the number of folds, all you need to do is find n. So to solve 2 to the power n, you first have to isolate it. 2 to the power n equal, you bring this whole thing to this side and also change the sign, which is divide. 3.84 multiply 10 to the power 5 divide